It doesn't matter which field of science you're aiming to study, you will come across different ways of collecting data. So let's have a look at them. You can collect data through experimentation, surveys, case studies, naturalistic observation, descriptive research, or through correlational research. Now this is a reference slide as we go through. First up, experimentation. We're going to look at the characteristics of an experiment and the two basic designs of experiments. So, if you can control an external environment, manipulate the variables you're observing or investigating, and measure the effect of the manipulation of variables, then you've performed an experiment. Now there's two basic ways to design an experiment. There's within and between groups. A within group exposes the same person to every environment, and between groups exposes the same group of people to different environments. Now there's a few issues with this, because in a within group, if you've got an individual going through too many environments, the influence of each environment will run to the next one, and the individual may not be operating at their best as they did in the first experiment. They may get hungry, they may get annoyed, and you don't really have as good test results. And with between groups, you can't guarantee that all people would react to the same stimuli or the same situations. So next up are surveys. So these involve gathering information from individuals directly. So we're going to look at how surveys could go wrong, the difference between a population and a sample, what random sampling is, and how to obtain a representative sample. So a survey could go wrong because it relies on self-reports, and this can be distorted by social desirability bias, which is the act of altering one's answer in accordance to what society deems as acceptable. A survey doesn't mean you can draw cause and effect conclusions just because someone responds yes or no. It doesn't say why they said yes or no. It just explicitly answers the question. And often there can be faulty random sampling when you randomly sample a population, but there is a less than 5% chance. So 95% of the time you do have a decent random sample. So the difference between a population and a sample. A population is a group we are interested in gathering information from, so let's say Australians. A sample is a subset of that population, so it could be Hobart. So we can't test an entire population, but we can test a sample. So random sampling is a method whereby every individual has an equal opportunity of being chosen. Like the Powerball, every number has an equal opportunity of being chosen. So what is a representative sample and how do we obtain it? So a sample which represents the important characteristics of a population, we can obtain that through random sampling. So let's say we wanted to find out how many people had red hair in Ireland. We could randomly sample 50 people and we could sort of gain a representative sample of how many people have red hair in Ireland. Although of course the bigger the sample, the more accurate it is of the population. So next up are case studies. So though the case studies are an in-depth analysis of a specific group, it is beneficial in providing insight into a rare phenomenon, but we can't draw broad conclusions from a specific group. Another benefit of case studies is that it can challenge popularly held beliefs, and it can also be a source of discovery. But we do need to be careful when looking at archival case studies or any case study in general, because sometimes the information collected could be biased. It's a very rare phenomenon and only a few people are around to witness it or study its initial event. So naturalistic observation. This is observing individuals and recording behaviour without intervention. So bird watching, watching kids play on the playground, or just sitting up in a tree house and watching apes swing through trees. Now the problem with naturalistic observation is that you can't deduce the exact reason as to why someone would do something. There are also differences in operational definitions, which is, when scientists do observe something happening, let's say this person observes that a bird leaves a branch in a specific manner, which indicates that it is more extroverted. It would be difficult for other scientists to exactly map how that bird left that branch at what angle, unless they've got advanced technology. But if you're just watching someone, it's mostly left up to the bias of the person observing. And the obvious problem with naturalistic observation is that the presence of the researcher may affect the behaviour. I mean, this isn't exactly the best camouflage, is it? So, good luck to this researcher. Descriptive research. Descriptive research actually encompasses surveys, case studies, and naturalistic observation. Its purpose is to describe the characteristics of a population or a phenomenon under study. In psychology, it is used to determine how humans behave. And lastly, correlational research. So, we're going to look at, there's a few sections here, and we're going to look at why we can't study cause and effect relationships with correlational research. We're going to look at the bidirectionality problem, the correlation coefficient, and interpreting the R value. So, what correlational research does is determine relationships between events or people, and it usually involves measuring the degree of similarity between two people or groups. It could be more. Now, the reason why we can't study cause and effect relationships is because correlational research tells us how much something is correlated and not why. So a good way to remember this fact is that correlation does not imply causation. Please remember this. Now, the bidirectionality problem leads on to correlation does not imply causation, because we don't know which variable causes the other variable to change. If you're measuring the degree of x, the relationship between x and y, you don't know whether y is causing x or x is causing y. We also don't know if the behavior of one variable is affected by another variable, and this affects the validity of the study, as the researchers may be unknown to all influences on a variable. So let's take everybody knows that when you open a tap, generally water comes out and fills a glass. So you could say that how quickly the glass is filled up with water depends on how much you open the tap by. So this could be your x and the tap could be your y. But actually that tap is connected to a system of networks, and its original source is actually the amount of rainfall from the sky, because it feeds into a dam and it comes into this water, provided that you are given water by dam system and not by other means of water providation. I don't think that's a word. That's one way. So this is a good example of bidirectionality. Well, not bidirectionality, but causation does not imply causation. So this is a funny meme. When you go along into correlation does not imply causation, an important fact is people have often discovered that when they measure two variables that are unrelated, they do seem to find some sort of correlation. And it's like, yeah, they're correlated. We don't know why though. So why do we use them if there's so much trouble? You've got bidirectionality problems, you've got correlation does not imply causation. Well, in labs, we can determine accurate correlations as we can control a majority of the experiment. We can also use these types of studies to figure out abstract variables such as happiness, success, sadness, other types of emotions in humans. We can also, once we do have a reliable correlational experiment, we can predict future variables and changes in their effects. So next up is the correlation coefficient, which is a statistic which indicates the direction and strength of the relationship between variables. We denote this as R. It is also known as the R value. You can call it the correlation coefficient or the R value, but R value is obviously quicker to say. So, a positive R value means that as one variable increases, so does the other, and of course if that variable decreases, the other variable will also decrease. A negative R value indicates the increase of one variable will cause a decrease in the other. And of course the decrease of one variable will cause an increase in the other. So an important thing to remember that what the number of an R value means. So if it's less than 0.3, it's weak. If it's between 0.3 and 0.5, it's moderate, it's okay. But anything above 0.5 is extremely strong. And 0 implies no correlation. X and Y just don't affect each other at all. So as you can see here, this would be a moderate correlation. Well, it's sort of on the line there. It's pretty good. It's not too bad. It's quite good. So you can sort of see that there's a correlation, high negative, negative 0.9, perfect negative, negative 1. I don't think there is ever a perfect correlation possible in psychology. That would be a revolutionary discovery. So in summary, correlational research, we had a look at correlational research, naturalistic observation, case studies, experiments, descriptive research, and surveys. Now, the last thing I want to leave you guys with is don't forget about R values. They're probably the most important thing. Well, everything's pretty much important. You know, this is quite a lot of content, but just don't forget what these R value means. Write it down somewhere. So hopefully you now understand that, you know, scientists just don't sit around in labs all day. They actually go out into the world and they test and they make mistakes and they're doing their best to provide us with answers. Thanks for listening.